Hi, and welcome to Challenge 9, entitled The Farm Problem. In this challenge, a farmer is asking you to tell him how many legs can be counted among all his animals. The farmer breeds 3 species: chickens with 2 legs, cows with 4 legs, and pigs with 4 legs. The farmer has counted his animals and he gives you a subtotal for each species. You have to implement a function that returns the total number of legs of all the animals. And you have your usual examples to fully understand the problem. And it's important to note that the order of the parameters is chickens, cows, and then pigs. So remember that when you're going through these examples and trying to see why they make sense and return the right result. So on to the code. Now's your chance to pause and have a go at it. Otherwise, we'll get underway. I'm going to be a little verbose here and write things out to hopefully explain things better, and then we'll do a condensed version at the end. So you notice this returns an integer, and I'm just going to make a local variable here and call it something appropriate so it's clear what is being returned. Total num legs. Do something like that. And so you know that chickens have 2 legs, cows have 4, and pigs have 4. I'll do my usual method of defining some constants for that, even though it's a little bit of overkill here, but we're trying to get into good practices. Public and chicken 2. Okay. Let's make them for cow and pig as well. Remember, they had 4. And then you could do something like total number of legs. Yeah, we'll break it out just so we don't have one giant line. Legs plus equals. This is a shorthand for writing total number of legs equals total number of legs plus whatever I add here. So just so you know that, in case we haven't covered that. The chickens passed in times number of legs per chicken. And you can copy that and do the same for cows and pigs. But make sure you update and cow. And then return what was asked for. Okay, I think that covers it. We'll do the check in case I did something bad and it doesn't compile. Let's see what we get. Thinking. Let's see if we can see anything. Number of legs per chicken is 2. Cows, 4. Chickens, cows, pigs. All seems to line up. Okay. This method name is pretty poorly named. I would have called that get total legs for animals or something like that. This is not clear at all, so don't name your methods like that. And again, this was a overly wordy way of doing it, but it makes it crystal clear what these variables represent. Okay, so it liked this, and then as you become more comfortable, this would be a little too much, we'll cut it down. So instead you could have done Maybe you got this. You'll see that's a big line that goes off the screen. Typically, when you're developing, you'd be able to see more than this little section if you were in Visual Studio or something like that. But generally, you don't want your lines to run off the screen. That's considered a bad coding practice. It's just not neat. It's annoying for people to have to scroll to read everything. You could break that off and put part on a new line. Maybe we could even do that just to show how that would be done. So we don't need any of this. This problem's simple enough where people are going to be able to readily understand what you mean here. There's something else to note that you may be concerned how the computer knows which operations to perform when, and that has to do with the order of operations. Multiplications take precedence over addition, so it's going to do these multiplications first and then add all of those at the end. So let me copy this, make sure this works too. We'll refresh. That will give us a clean slate. And we'll put it in place here. And let's make sure I didn't do anything stupid here. So this is a nice shortened version. In general, you want to keep your function sizes very small. If you can get away with, a few lines of code, that's great. Things that are small are very simple to understand. The problem, especially for beginners, is to run on and make huge functions that span tens or even hundreds of lines. And it's hard to conceptualize what's going on with a function that's so big or a class that's so big. So it's really important to always factor pieces out into very small bits, and then you're sort of integrating each of those bits, composing them to make your solution. And this thing is really slow today. Must be the heat. We should get the all clear though. Make sure. Check. But yeah, this wasn't a very realistic example. Very much for teaching purposes only. But there you have it. We passed here too, and this maybe gave you some insight into order of operations. You can go online and check the Microsoft Docs or other websites if you search for that phrase, and it'll give you the order of all of them. So, thanks for watching, and see you in the next video.